The topic of this video is truth tables. It is part 1 of 3. Truth tables can do 3 things for us, and in this video we're going to cover the first of those 3. Truth tables can help us categorize the truth conditions of sentences. And sentences can be logically true or a tautology, logically false or self-contradictory, or third, they can be logically contingent, and we'll say what all those mean. A sentence is logically true if and only if it is true simply because of its logical structure, or a different way to put it is, in a truth table, the column for the main operator is all T's, and we'll have a lot to say about what that means. So take the sentence, either the Cardinals won the game last night or the Cardinals did not win the game last night. We would translate that into our propositional logic syntax as C disjunction negation C, or C or not C. And that is true simply because of its logical structure. You don't have to know anything about how the game went last night, and you can know that it's true that either the Cardinals won the game last night or the Cardinals did not win the game last night, because that is a logically true sentence. It is a tautology. A sentence is logically false if and only if it is false simply because of its logical structure, or to put it differently, in a truth table, the column for the main operator is all F's. So take the claim, Star Wars won an Oscar and Star Wars did not win an Oscar. And we would translate that into our syntax for propositional logic, S and not S, or S conjunction negation S. And you don't have to know anything about Star Wars or the Academy Awards to know that this is false because it's logically false. It's false simply because of its logical structure. Any sentence that has this structure, S and not S, is logically false. It's self-contradictory. And then last, a sentence is logically contingent if and only if it is either true or false, not simply because of its logical structure, but because of the facts in the world. Or, to put it differently, in a truth table, the column for the main operator has at least one T and at least one F. So take the sentence, if you are in Los Angeles, then you are in California. We would translate that as L conditional C. That is logically contingent. That's not true simply because of its logical structure. That's true because of the facts in the world, because it's a fact that Los Angeles is in California. It could have turned out maybe that they drew the lines differently and Los Angeles is in Arizona or something like that. But because of the facts in the world, it's true that Los Angeles is in California, so therefore it's true that if you are in Los Angeles, then you're in California. Again, that's not true simply because of its logical structure. That's true because of the facts in the world. So again, sentences can be logically true, or tautology, logically false, self-contradictory, or third, logically contingent. And truth tables can help us determine which category a particular sentence falls into. One thing to keep in mind, and I will link the video where we went over these previously in the description of this video, these are 5 rules that you have to keep in mind in order to do truth tables. You kind of have to either commit these to memory or at the very least have these ready maybe on a notepad or something when you're doing a truth table. These are things you have to know in order to complete a truth table. These 5 rules: conjunction, disjunction, conditional, biconditional, negation. To complete a truth table, you must complete these 3 steps. Set it up, fill it in, evaluate it. Set it up, fill it in, evaluate it. So let's do our first truth table. Construct a truth table to determine whether the following sentence is logically true, logically false, or logically contingent. If P and Q, then P. So the first thing we have to do is set it up. We have to set up our truth table. First thing you do is you draw a cross of sorts. In the upper right-hand corner, you put the sentence that you're going to evaluate. In the upper left-hand corner, you put every simple sentence that appears in that complex sentence. In the lower left-hand corner, you put every possible scenario about the truth and falsity of P and Q. They could both be true, P could be true and Q could be false, P could be false and Q could be true, and they could both be false. So now we have set it up. Now we have to fill it in. Okay, to fill in a truth table, you've got to keep 2 things in mind. You have to be able to analyze the sentence in terms of its parts, And you have to keep in mind those 5 rules. A conjunction is only true when both conjuncts are true. A disjunction is only false when both disjuncts are false. A conditional is only false when the antecedent is true and the consequent is false. A biconditional is only true when both components are true or both components are false. And a negation is only true when the sentence being negated is false, and vice versa. So you have to know those 5 rules, and you have to be able to analyze the sentences in terms of their parts. This is a conditional. The antecedent is a conjunction. The consequent is a simple sentence. And when you fill in a truth table, you're going to have to fill in 1 column for every operator. So here we have 2 operators. We have a conjunction and we have a conditional. And you say, which one do I have to do first? You always go from inside the parentheses to outside the parentheses. Or you always go from the operator that is quote unquote operating on the least amount of information to the operator that is operating on the most amount of information. You say, okay, we have 2 operators here. We're going to have to fill in 2 columns. Maybe I want to start with the conditional. Can I start with the conditional? Well, in order to fill in this column, a conditional is only false when the antecedent is true and the consequent is false. You would have to know the information for the antecedent and the consequent. The consequent is P. You have that information over here. On line 1, P is true, 2, P is true, 3, P is false, 4, P is false. So you do have the information for the consequent, but you don't have the information for the antecedent. The antecedent is this conjunction, so we have to get that first. So it's a conjunction of P and Q. We look over here and we follow that rule. A conjunction is only true when both conjuncts are true, like on line 1. So our sequence is T, F, 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 because again, on line 1, both conjuncts are true, but on lines 2, 3, and 4, at least one conjunct is false. Now we can fill in the conditional. The antecedent of the conditional is the conjunction, which we just filled in, and the consequent is P, which is over here. So we follow that same rule. A conditional is only false when the antecedent is true and the consequent is false, like in line... Oh, look at that. There's no lines like that. This is true. In line 1, you have true antecedent and a true consequent. In line 2, you have a false antecedent and a true consequent. You have a false antecedent and a false consequent on line 3, and then false and false on line 4. So in each line, it comes out as true, because in no line is the antecedent true and the consequent false. So now we filled our truth table in. Now we have to evaluate it. We look at the main operator column, which is the column that, if you've done it correctly, should be the last column that you fill in. And we see the column for the main operator is all T, so this sentence is logically true. If again you're wondering what the main operator is, ask yourself this question: what type of sentence is this? Yes, it's a complex sentence, but it's also a conditional, right? It's a conditional, that's the main operator, that's the idea. It's a conditional where the antecedent is a conjunction and the consequent is a simple sentence, but it's a conditional, so the conditional is the quote-unquote main operator. Here's another one for us to do. Construct a truth table to determine whether the following sentence is logically true, logically false, or logically contingent. P and not P. First thing we do to set it up, make our cross. Upper right-hand corner, we have the sentence we want to evaluate. Upper left-hand corner, we have the one simple sentence that appears in that complex sentence. In the lower left-hand corner, we have every possibility. And because we only have one simple sentence, there are only 2 possibilities. P could be true or P could be false. Now we have our truth table set up. Now we have to fill it in. We have, again, in this example, 2 operators, and there is a specific order that we have to go in. What is the main operator? The main operator is the conjunction. It's a conjunction of P and not P. So the conjuncts are P and negation P. So we're going to fill in the conjunction last because that's the main operator. What we have to fill in first is negation P. Right? The rule for negation is a negation is only true when the sentence being negated is false, and vice versa. So when P is true, not P is false, and when P is false, not P is true. So that's our column there. Now we can fill in the column for the conjunction. It's a conjunction of P and not P. So we look over here, and we look over here, and we follow the rule. A conjunction is only true when both conjuncts are true. In line 1, it is not the case that both conjuncts are true. Same thing with 2. So both of them are going to be false. Now we filled in our truth table. Now we have to evaluate it. The column for the main operator is all F's. So this sentence is logically false. This sentence is self-contradictory. Here's another one for us to try. Construct a truth table to determine whether the following sentence is logically true, logically false, or logically contingent. Draw our cross. In the upper right-hand corner, we have the sentence that we want to evaluate. In the upper left-hand corner, we have every simple sentence that appears in that complex sentence. In the lower left-hand corner, we have every possibility. Right? They could both be true, they could both be false, or one could be true and one could be false, and vice versa. Right? Now we just have to fill it in. Now we have 3 operators, so we're going to have fill in 3 columns. What's the main operator? The main operator is a conditional. So we have to fill that one in last. We have to fill in first the disjunction over here or the conjunction over here. It actually doesn't matter what order you go in. You could start here or here. The disjunction column is TTTF because the rule for disjunction is that a disjunction is only false when both disjuncts are false. So how do we get this? We look over here. On line 1, P is true and Q is true. On line 2, P is true and Q is false. Line 3, P is false and Q is true. And on line 4, false and false. So line 4 is the only line in which both disjuncts are false. How about the conjunction over here? Again, we look over here for that information, but we apply the rule. A conjunction is only true when both conjuncts are true. So on line 1, they're both true, but on line 2 through 3, but on lines 2 through 4, at least one of them is false. Now we can finally fill in the conditional, which is the main operator. The antecedent is over here in this column. The consequent information is over here in this column. And we apply the rule, a conditional is only false when the antecedent is true and the consequent is false. You have true, 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 false, false, false. So lines 2 and 3 are the only lines in which you have a true antecedent and a false consequent. So the column here is going to be true, false, false, true. We filled in our truth table. Now we can evaluate it. The column for the main operator has at least one T and at least one F. So this sentence is logically contingent. Here is another example. Construct a truth table to determine whether the following sentence is logically true, logically false, or logically contingent. Negation P or P and Q. Okay, here's our cross. Upper right-hand corner, we have the sentence we're going to evaluate. Upper left-hand corner, every simple sentence that appears in that complex sentence, and then all of the possibilities. Now we can fill it in. For this sentence, this is a negation. It's a negation of a disjunction. And for this disjunction, it's a disjunction of P and a conjunction. So remember, we have to start from the inside and work our way out. So we have to do the conjunction first, then the disjunction, and then the negation. So for this conjunction, where we have to start, it's a conjunction of P and Q. It's only true when they're both true, like in line 1. In lines 2, 3, and 4, at least one of them is false. So our column is T, F, F, F. Now we can fill in the disjunction column. Again, it's a disjunction of P, which is over here, and the conjunction, which is over here. It's only false when they are both false, like on lines 3 and 4. So we have T, T, F, F. And then the negation is a negation of the disjunction. Essentially, the negation is saying the sentence inside the parentheses, which is a disjunction, is false. So you just take this column and you flip it. Every time it's true, the negation is false, and vice versa. And now we can evaluate our truth table. The column for the main operator has at least one T and at least one F, so the sentence is logically contingent. Here's another example for us to try. We draw our cross. Upper right-hand corner is the sentence that we want to evaluate. This one's going to be a beast, as you can see. Every simple sentence that appears in that complex sentence. And because we have 3 simple sentences, we're going to have 8 possibilities. This represents all 8 possibilities, but none of them repeat. You can sort of see the pattern here. They're all true, they're all false, or P and Q is true and R is false, and you see that every possibility is represented. Now we can fill in our truth table. We have 1, 2, 3, 4, 5 operators, so we're going to have to fill in 5 columns. What's the main operator? This is a conditional. The conditional is here. That is the main operator. The antecedent is a conditional. It's this conditional. The consequent is a conditional. It's this conditional. Over here, for the antecedent of this big long conditional, again, it's a conditional. And for this conditional, the consequent is the conjunction. So we look over here, Q and R, it's only true when Q is true and R is true. If either one of them is false, it is false. So if you look over here, Q and R, on line 1, they're both true. On line 5, they're both true. So you have T, F, 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 T, F, F, F. Because in every other line, at least one of them is false. Now we can fill in the column for this conditional. The antecedent is P. The consequent is Q and R. So we look at the P column and we look at Q and R column. And we apply the rule. A conditional is only false when the antecedent is true and the consequent is false. You have true, 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 false, true, false, true, false, false, true, false, 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 and false, false. On lines 2, 3, and 4, you have a true antecedent and a false consequent, but those are the only lines in which you have that combination. So this is our column here. T, F, 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 T, 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 T. Now we have the antecedent column for this big long conditional. Now we have to get the consequent. The consequent, we said again, is itself a conditional. The antecedent of that conditional is P and Q. So we look over to the P and Q column, and we apply that same rule. A conjunction is only true when both conjuncts are true, like on lines 1 and 2. On the rest of the lines, there's at least one that's false, so T, T, F, 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 F. Now we can fill in this conditional. The antecedent column is here. The consequent column is the R column. It's only false when you have a true antecedent over here and a false consequent, which is over here. And the only time that we have that is line 2. You have a true antecedent and a false consequent, so the conditional is false. And now we can fill in this conditional column. What's the antecedent? The antecedent, again, we said is this conditional, and the consequent is this conditional. So we look at this column and this column, and we apply that same rule. A conditional is only false when you have a true antecedent and a false consequent, like on lines. If we look, we don't have any lines like that. On no line do you have a true antecedent and a false consequent. No line do you have that, so this gets all T's. Now we just have to evaluate our truth table. And we see, yep, the column for the main operator is all T's, so this sentence is logically true. Here's yet another example for us to do. Draw our cross. Upper right-hand corner is the sentence that we're going to evaluate. Upper left-hand corner is every simple sentence that appears in that complex sentence, and then all the possibilities in the lower left-hand corner. Now to fill in our truth table, here's something you might notice, that whenever you have the negation of a simple sentence, you can fill that in pretty quickly. If you look over here, you have the P column. Not P is, you're just going to flip it, right? Every time P is true, not P is false, and vice versa. And so it's going to be the same thing over here. And for not Q, every time Q is true, not Q is false, and vice versa. So now we only have 1, 2, 3 more columns to fill in for a total of 6. Our main operator is the biconditional here. So before we fill that in, we have to fill in the left-hand component, which is here, the conditional, and the right-hand component, which is here, the conjunction. I can start with the conditional. It's a conditional of negation P and negation Q. So this is the antecedent column, this is the consequent column, and you just follow that same rule. It's only false when you have a true antecedent and a false consequent on line 3, but that's the only line where you have that. So it's TTFT. Now we fill in the conjunction column. It's a conjunction of negation P and Q. So you look at this column and the Q column, and you apply the rule. A conjunction is only true when both conjuncts are true. And in line 3 is the only line in which both conjuncts are true. So now we can fill in the biconditional. And we apply the rule. A biconditional is only true when both components are true or both components are false. And again, in this case, the components are this conditional and this conjunction. So when are they both true or when are they both false? In other words, when do they match? Well, in line, you have true, false, don't match. True, false, they don't match. False, true, they don't match. Line 4, true, false, they don't match. So they get an F in every row. Now we can evaluate our truth table. The column for the main operator is all F's, so this sentence is logically false. Here's yet another big truth table for us to complete. Draw our cross. Upper right-hand corner is a sentence that we're going to evaluate. Every simple sentence in that complex sentence, every possibility, and now we can fill in our truth table. This is a conditional. The conditional is the main operator, so that's what we're going to have to fill in last. Let's start with the consequent of this conditional. The consequent of this conditional is a negation. So it's a negation of a disjunction. The consequent of this conditional is a negation. It's a negation of a disjunction. So now we have to fill in the disjunction. What are the disjuncts of this disjunction? It's a conjunction and a negation. So we have to fill in those first before we can fill in the disjunction. So the first thing we can do is we can look to not Q here. Every time Q is true, not Q is false, and vice versa. And we see over here we can do the same thing with not R. Every time R is true, not R is false, and vice versa. Now, again, moving from inside to outside, or from operating on the least amount of information to operating on the most amount of information, now we can fill in the conjunction. Again, it's a conjunction of P and not R. So we look at the P column and the not R column, and we apply the rule. A conjunction is only true when both conjuncts are true. We look on lines 2 and 4. Those are the only lines in which both conjuncts are true. So we get F, T, F, T, F, 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 F. Now we can fill in that disjunction. Again, it's a disjunction of the conjunction and the negation. So we look at this column, and we look at this column, and we apply the rule. A disjunction is only false when both disjuncts are false, like in lines 1, 5, and 6. So it's F, T, 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 F, F, T, T. But the negation out here is saying the sentence inside this parentheses is false. In other words, the negation is saying this disjunction is false. So you take the disjunction column and you just flip it. Every time the disjunction is false, the negation of the disjunction is true, and vice versa. So we have, for this conditional, the consequent column, which is here. Now we have to get the antecedent column for this conditional. The antecedent is a biconditional. It's a biconditional of a disjunction and a simple sentence. So we have to fill in the disjunction first before we fill in the biconditional. We look over here. It's a disjunction of P and Q. So we look at the P column and the Q column, and we apply the rule. A disjunction is only false when both disjuncts are false, like in lines 7 and 8. Those are the only lines in which P is false and Q is false. and every other line, at least one of them is true. So true, 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 false, false. Now we can fill in the biconditional. Again, it's a biconditional of the disjunction and are. So we apply the rule, a biconditional is only true when both components are true or both components are false. In other words, when they match. When does the disjunction and are match? In lines 1, 3, 5, and then 8. And now finally, we can fill in our main operator column. It's a conditional. The antecedent is the biconditional. The consequent is the negation. So we apply the rule. Looking at this column and this column, looking at the biconditional column and the negation column, a conditional is only false when the antecedent is true and the consequent is false, like in lines 3 and 8. So those lines are false, the rest are true. Now we can evaluate our truth table. The column for the main operator has at least one T and at least one F, so this sentence is logically contingent. So to sort of wrap up the video, here are some more examples for you to try. If you want, you can pause the video here and construct a truth table to determine whether the following sentence is logically true, logically false, or logically contingent. And then I will reveal the answer after you unpause. The column for the main operator is all F's, so the sentence is logically false. Here's another example for you to try. Construct a truth table to determine whether the following sentence is logically true, logically false, or logically contingent. And here is the answer. The column for the main operator is all T's, so this sentence is logically true. And then one more example. Construct a truth table to determine whether the following sentence is logically true, logically false, or logically contingent. And here's the answer. The column for the main operator has at least one T and at least one F, so this sentence is logically contingent. And that includes part 1 of our series on truth tables here. This might be the type of thing that you have to go back and watch a second time. I know there's a lot of information in this video. Repetition and practice is the name of the game with this stuff, so give it a try.